Welcome to McCardle Math Academy, everybody. In this video, we're going to be looking at an alternative approach to shading Venn diagrams in order to determine what certain sets look like. A lot of times you'll be asked to find what a set looks like, for example, A intersect B intersects C's complement, and you'll need to take a Venn diagram and try to figure out where to shade to represent this particular set. Now this can be done with colors, but it can also be done with this alternative approach that I'm going to show you now. Now before I get into the approach, I just want to remind you of two very basic definitions. The first is for a union, and the second is for an intersection. So for a union B is the set consisting of elements that are in A or B or both. So imagine you're joining together two things, you're taking a union of them. And therefore when you read A union B, think A, elements of A, or elements of B, and we're including everything from both. Now, an intersection, A intersect B, is the set consisting of elements that are in both A and B. So this is more restrictive. And the way you read it is that the elements have to be in both A and B. Okay, so from here on out, I want you to think of the union as or and the intersection as and. And I'm going to explain what this means as we move forward with examples. So let's look at this particular example here, where we're asked to find A intersect B intersects C's complement on the Venn diagram. So I want to know exactly which region this is on our Venn diagram. So there's a couple approaches. Again, the first approach would be to shade with colors each of the individual regions, A, B, and C's complement, and then try to understand how the intersection works with that. So A, to shade A, I'm going to use green. So I just shade the entire circle of A. That encompasses numbers 1, 2, 4, and 5. I'm going to do the same for B and the same for C's complement. So here we have all the same colors, three colors on the graph here. And now we look back at what the intersection means. And you can kind of think about it in your head. If you're trying to find an intersection, we're looking for where the colors, green, purple, and red all intersect. And we interpret the intersection as elements. We have to find all elements that are in both A and in B and in C's complement, so that are in green and in purple and in red at the same time. And I'm going to shade that in blue here. It's actually just going to be this little wedge on the inside, which is just the number 2 as it was previously marked. Now this approach works great, but sometimes it can be hard to see, and if you don't have colors, you might feel as though this is particularly hard to do. So I have another approach. And this approach would be to use the numbers 1 through 8 to your advantage. So we're first going to write A as what it is in numbers. So A encompasses 1, 2, 4, and 5. The same can be done for B, where B encompasses 2, 3, 5, and 6. And the same can be done for C's complement. So outside of the circle C, you have 1, 2, 3, and all of 8. So I'm going to write that here. And since we're looking for the intersection, we're trying to find the regions that are common to the green, purple, and red sections here. So I'm going to grab a pen here and try to see which of the regions are common to the three groups. You'll notice if you look closely that the only thing common to them all is the 2. All the other ones, for example, 4 is not in purple, 5 is not in red, 3 is not in green, 1 is not in purple. So all of those other ones can be eliminated from this intersection because it's not common to all three. And therefore we get to the same point that we got to before, that our region, A intersect B intersects C's complement, right up here, is drawn in blue. It's just the region 2. So this can be a pretty quick approach, and you can actually do it in your head once you get quick at it, and that'll help you solve a lot of problems. Let's look at how it works with unions. Let's do a similar example, but this time with A union B complement. So again, I'm going to do A in red. I don't know if the colors are the same as what I did before. B complement in green. And I'm going to shade my Venn diagram so we can see where that region is. There you have the regions drawn, the green and the red. And we think about the union. The union reminds me of a marriage, joining two things together. So we're going to be joining the red and the green region. So taking elements that are in A or in B complement, and therefore anything that is shaded in green or in red would be included in this set. And I'm going to do that, I'm going to highlight that actually in blue. So I'm going to highlight our set here. I'm going to highlight in blue on the Venn diagram. So there you have our set. Now, if we use the other approach, The other approach will be to list, A and B's complement in terms of what they are with the numbers 1 through 8. So I'm going to do that here for us. So you'll see here, B's complement, for example, is all of the regions that are not in B. So here's B, this circle here. 1, 4, 7, and 8 are not in B, so that's why I've written that as I have. Now the union is the joining together of the red and the green here. So it's going to consist of anything that's in red or in green. So red has 1, green also has 1, but we won't write it twice. Red has a 2, red has a 4, green also has a 4, but again we won't write it twice. Red has a 5, green has a 7, and green has an 8. So the region A union B complement will consist, I'm going to draw it again with the highlighter, of region 1, so there's 1, 2, I shade 2, 4, 5, 7, and then all of 8. So we arrive at the same exact point that we had before, where we didn't have to use colors to try to find where everything overlaps. All right. So I hope this helps, guys, as a technique, and I'll see you next time.